Hello everyone, my topic is fabrication of IC. Myself Sasikant Chaudhary. This is the first integrated circuit. It's a bipolar logic invented in 1960s, named as Motorola 1966. And this is the second picture. Intel 4004 microprocessor invented in 1971. It has 1000 transistors and operating at the frequency of 1 megahertz. So Moore's law. Actually, it states that the transistor in an IC gets doubled after every 18 months. As you can see, the wave chart, it's increasing. Okay, so let's move to the steps of fabrication. The first step is wafer preparation. Under wafer preparation, crystal growth of wafer slice and polish are done. Second, wafer processing. Under wafer processing, epitaxial growth, oxidation, etching, photolithography, diffusion, ion implantation, metallization are done. The third step is testing and packaging. So, making of an wafer. The wafer is a thin slice of semiconductor material such as silicon crystal upon which a microcircuit are constructed by doping. A small chunks of polycrystalline silicon are placed in the quartz silica crucible with the small amount of chemical dopant elements needed to produce either N-type or P-type silicon. The crucible of a silicon is heated to the molten state with the help of clamp. A kneaded or small crystal of doped silicon is lowered into the melt. Once the seed crystal touches the surface of the silicon, the wet temperature is reduced as a temperature. The silicon melts attach themselves with the seed crystal. Once the crystal starts to grow, the seed crystal is raised out of the silicon. The seed is rotated in the one direction while the crucible in its holder is rotated in the opposite direction, and the single seed crystal becomes a huge ignite. And this process is a Zykolysk method of the crystal growth. The crystal of a silicon sliced into round crystal known as wafer. The wafer is thin, clean, polished and checked for flatness and defect before it being used. One wafer could have hundreds of chips in it. So next, moving to the epitaxial growth. Epitaxial growth, epitaxial growth can be defined as growing a new layer of silicon on the top of another layer of silicon while maintaining the lattice structure is called epitaxial deposition, which can be done in several ways, and one of the ways is chemical vapor deposition. The steps can be the wafer is placed in the quartz tube that can withstand very high temperature. Second, at one end, highly reactive gas are formed. Third, the reacted gas travel through the tube until they encounter the wafer. And the fourth, due to the low temperature of the wafer, silicon in the mixture condenses on the surface, which gives a nice epitaxial growth, as you can see in the picture. And the third step is oxidation. First of all, oxidation is of two types: wet oxidation and dry oxidation. In wet oxidation, when the oxidizing atmosphere contains water vapor and the temperature is between 900 degrees Celsius to 1000 degrees Celsius. In this, silicon gets oxidized to SiO2 and also hydrogen gas is generated. However, quality of the oxide grown is comparatively poor. Dry oxidation. Oxidizing atmosphere is pure oxygen with the temperature between 900 degrees Celsius to 1200 degrees Celsius for different growth rate of oxidation. This process is slow, but the quality of oxide growth is superior. And the third point is etching. It's a process of removal of unprotected material. Types, it's of two types: dry etching and wet etching. In wet etching, wet chemical etchants are used by immersing the wafer into the bath of liquid chemical. The exposed film will be etched away, leaving unetched those regions of the film that were masked, and the photoresist or other films are common where etched are silicon dioxide or is hydrofluoric acid. And in dry etching, a low pressure of gas is used in the chamber by applying high electric field across the two electrodes. Some of the gas atoms are ionized, producing positive ion and free electron, and the creating of plasma energy is supplied by an RF generator at 13.56 megahertz. The, the next step is photolithography. It's a process of transferring an image from a photolithograph mask to a resultant pattern on a wafer. A photoresist polymer film is applied to the silicon wafer, dry, and then exposed with the proper geometrical pattern through a photomask to UV light or a radiation. A photoresistive positive or negative is placed over the substrate. Photolithograph is a fundamental part of every step in the IC fabrication process, whether for implantation, doping, epitaxial layer formation, or an other surface. As you can see in the diagram, a UV light is exposed to the exposed with the photoresist on the silicon dioxide. And the next part is diffusion. It is a process of doping a wafer causing creation of p-type or n-type region where the silicon surface is not protected oxide. It consists of two states, pre-oxidation and drive-in oxidation. In pre-oxidation, dopant atom mixed with an inner gas are introduced into the furnace at 1000 degrees Celsius. The atom diffused on the thin layer on the surface of silicon. In drive-in, the wafer is heated in nitrogen gas with dopant. This distributes the surface diffusion deeply on the body. And the second part is the ion implantation. In ion implantation is a selective doping process that drives ionized dopant, boron, arsenic, phosphorus atom into the semiconductor wafer at a room temperature. The resulting atoms are accelerated by high voltage and form with narrow beam and that is directed into window pattern in the wafer's surface. The ionosphere enough energy penetrate the surface and then slow to rest within this wafer at the depth determined by the manufacturer. The next step is metallization. Metallization is a process of deposition of conducting material to form interconnection leads between the circuit component part on the surface of the chip. Due to the various advantages, aluminum is most commonly used for various metallization process. How it is done? A chamber containing large block of desired metal is suspended above the wafer. The metal will be blasted onto the wafer to form a new surface. The air is sucked out and a small amount of argon pumped into the chamber. Argon atom turned into high energy plasma at very low pressure are subjected to high frequency, high voltage as a high energy argon atom. Smashed into the metal, they form metal atom to dislodge from the block. Flying into the plasma, the metal atom become ionized and stick onto the wafer. Conclusion. Hence we have learned various steps of fabrication. After this the fabrication are tested and packaged. For further information, for more information, you can visit these sites. Thank you.